Okay, now that we've imported our geometry, we need to actually set up some constants within the simulation that will help us to set grid sizes and the signal for the current distribution and things like that. So we're going to open this constants menu. Now some of these constants are already loaded when you open VSim, from pi all the way down to the electron mass and EV. Everything after that I've already added to the simulation. And it's kind of up to the user how much to add in these constant lists and how much to just hard code elsewhere. What I find is that using constants in this list then allows you to link them below, and if you link them in multiple places, then it gives you one place to change a value, and then it will propagate throughout the rest of your settings. So I find it nice to include a lot of constants and parameters up here, but it's completely user choice. Now I'm going to provide things like frequency here, which I know is, I said it was about 1.5 gigahertz. We were told it's actually 1.497, so that's what I've put in. The length of these cells I know is 10 centimeters, and that's from the center of one cell to the center of the next. So I put that in. Xmin, Xmax, these were values that were set. When I loaded the geometry the very first time, it asked me if I wanted to fit my grid to this object. I said yes, and these are the values it came up with. I put them in then as constants so that I could just have them in here and use them later on if I needed them for other dependent calculations. So we're starting our grid at minus 0.13 in X and going up to 0.23. In Y, so you can see the X direction is this red here, and we know that because the X up here is red. It's asymmetric in the X direction. It's not symmetric about 0. But in Y, it is symmetric about 0, negative 0.12 to positive 0.12. For the Z direction, we're on the negative side, so we're actually going from minus 1.1 to positive 0.1, and that will encompass our geometry. These other options here are only really important if you want to do a resolution scan, as in you want to change the resolution and see how the frequency changes. We know that if we resolve this object better, then our simulation should get more accurate results. And so we can flip this resolution switch, which here we've set to 0.08, to change how finely this simulation is gridded. And we can see that if I go to my grid and I turn on my grid, now I go back up to this resolution and it's at 0.08. If I put it to 0.02, the resolution will get much finer. So fine we can barely see it. So this not only adjusts the grid size, but also things like the simulation time step and simulation length, which will depend on the resolution of the simulation as well. So that's just a nice switch to have in, and I can talk more about that later. The suppression factor, I told you earlier that we turn the current density signal on and then off. This suppression factor is how low we want that signal to be by the end of our simulation. Because it's a Gaussian envelope in time, this gives us an idea of how long we need to run the simulation. dmFrac is to do with the Demetra fraction. There's documentation on it on the VSim website, and there are also papers by Day and Mitra. So suffice it to say 0.2 is a decent value for us. And finally the Cfl number, this is the Courant-Friedrichs-Lewy condition number. In this case we're saying 0.99, so we're going to set our time step to be 0.99 times the Courant-Friedrichs-Lewy condition, which will basically ensure that we have a sufficiently small time step. So these are all the constants I've used for this simulation.